My name is Jan Hadders. I'm born in the Netherlands, in Emmen, and I grew up on the farm. After my education in Dronten at the agriculture college, I went to Canada for a couple of years. When I came back, I took over the farm from my dad, and later on, I started Dacom in the beginning of the 90s.
I'm Gert Sterenborg. I'm product manager at CropX. Next to my job here at CropX, I have a farm together with my parents. After my education in Wageningen, I did my internship here at Dacom, and I never left since then.
The disease management system. We started in 1993 already thinking about it, because our crop recording system was evolved into a new system where it was possible to update the local computers, the disease management system. We started in 1993 of the farmers through a central data bank. I think for that time it was a very unique system. So we were able to provide farmers almost real time from data they needed to do something with. On the other hand, in that period, disease management in the Netherlands was a big problem, specific the late blight in potatoes, or the Phytophthora infestans, as you might call it. The usage of fungicides was so high at that time that the government threatened the farmers to cut it down, to put limits on the use of these fungicides, unless, the government said, unless you farmers do something about it. So that was the opportunity for us to build a system on the existing crop management system we had and do something for the farmer and make our product more usable for the farmer. We first looked what is available in the market and decided already pretty quick that that was not the way we wanted it. Those systems had all very rigid thresholds and were not really representing how the disease developed. So we started looking for information, and we found an older scientist, Mr. Turkenstein. He told us everything about the disease, and based on that we said, okay, we are going to develop a system that simulates the life cycle of the late blight. But we will add to it not only what happens during the life cycle, but also what happens to the crop, the influence of the fungicides that are used, and the climate around it. And we want to look ahead. And by wanting all these things, we put a big challenge to ourselves. We first looked what is available in the market and decided already pretty quick. It was built in such a way that the programmers made the program, but the people that knew about the late blight could fill in the data to manage the system. So they could, without using a programmer, they could change the outcome of an advice. The real challenge was to convince other people, the farmers, but not only the farmers, also the people that advise, that there is a certain moment where late blight, and let's talk in this discussion about late blight in potatoes, because it's the other fungus are roughly the same, but we put most of our effort in late blight. It is very difficult to understand that late blight is not something magic, but it happens at a certain moment because of certain conditions. You need 3 things to get late blight. You need spores, from the Phytophthora. You need leaves from a potato plant that are not protected by any chemicals. And you need the right weather conditions for the spores to germinate, penetrate, and come into the leaves. If these three elements is failing, you don't get a disease. It's a bit black and white, but that's how we looked at the system. One of the challenges we ran into was the lack of information about what is really happening in this life cycle. Does it take 1 hour for a spore to germinate and penetrate into a leaf? Or does it take 3 hours? And what is the effect of a resistant variety? Does it take 4 or 5 or 6 hours? And what temperature is relevant? To get real good information was a big challenge. Validating the system was always a big challenge. As I said, the information available was not always sufficient. We worked together with different research stations, sometimes universities, sometimes other governmental institutions, all over the world. They were all working on the late blight, and they liked to test our system. Also, we worked together with chemical companies. They wanted to test their new products, and they wanted to test our system. So we have had thousands, literally thousands of fields over many years where they would treat a field, a potato field or other crop, would treat it according to our system. And next to that, they would have other systems like the farmer system, the normal way to do, let's say every week, or the way the chemical company wanted it, or no treatment at all, which meant you had a high disease pressure. Based on that information, we could fine-tune our system. Another thing we did is we, together with a governmental institute in the Netherlands, we looked at first infections. So in the spring, when the potato crop emerged, you always got a message somewhere that an infection had taken place in the field somewhere. We would go to that field, we would look at the infections, we would estimate how old the infection was, when it occurred, then we would look back into our model in the system. Is it correct? Did we predict this infection? And if we were too late or too early, we could adjust the system according to it. Based on these first outbreaks, we also discovered, together with these institutes, where the first infections came from. Did they come from the farmers' fields? Did it come from, as the farmers thought, from hobby farmers? Or did it come from cull potatoes that are coming up from the harvest from last year? Or cull piles? And in the end, the conclusion was that cull piles, so these are potatoes that are dumped on the corner somewhere and they are not covered up, that they have in a very early stage, they produce already spores. And one of the results, which is also one of the results from our system, is that farmers get a yellow card when a cull pile like that, uncovered, is discovered. And when it's not covered within within 14 days or something like that, or a week, they get a red card and they get a fine. Because if you can prevent the first outbreak, you prevent late blight. Of course, that's an illusion, but we learned an awful lot from that. An important factor of getting late blight is the amount of spores that are above your field. And in the model, there's a submodel that calculates the number of spores. And it's different in different places, different institutes, they can count the number of spores that are in the air. And we compared that information, so these are real actual counts. It's too much to tell you how they did it, but actual counts with what the model predicted. And that was always when it's high, then we were high. It was a challenge to get right. But another way of analyzing is, if you do a good job, is by letting farmers using it. And in between the year 2000 and 2006, we had almost 1.5 million requests on the farmer's PC. The farmer would ask the system, do I have to spray or not? And we analyzed that, we could analyze that information, and about 75%, about 57% of the time they look at it, they got, there's no risk, you don't have to spray. And I'm specifically saying that because it's more difficult for a farmer not to spray than to spray. Because if you spray, you're protecting your crop. If you don't spray, okay, you save the money, but you're not 100% sure if that's the right way to do. So in our experience, it was always more difficult to convince the farmer, even after a longer period, of not spraying than to spray. One project we did that had a significant influence on disease management was a project with a chemical company in the United States. We worked together with 21 locations there, with universities, research institutes, some commercial properties over 2002 up to 2005, where our system was tested against normal use and the use of these universities. The end result was that Dacom needed 4.8 on the average applications per season, while the standard spraying method was 7.2. In the end, it was decided, because of complications, it was decided by the chemical company not to proceed and to introduce this in the United States. There were some things that come to my mind when I look at the beginning of introducing this system. It started out, the first farmers were close by in Overijssel, which is only 50 kilometers from Emmen. We had some good results there. Then we went to the south of the Netherlands, and they said, well, it's completely different here. So you cannot just apply your system in Limburg, in the south of Holland. Then we went to the UK, and they said the same. Then we went to Germany, and they said the same. Then they went to Japan, and they said, well, so you cannot implement your system here in Japan because things are completely different here. The trick is that lead blight is the same within limits all over. And when it's 18 degrees in the Netherlands and it's 18 degrees in Japan, the reaction of the lead blight is the same. So we always had to fight with the new area because they thought it was completely different, and we had to pay attention to that. What also happened quite often is that when our system was tested, and specific, I remember one in Ireland, a test in Ireland with a research station, where the objective was to treat one field according to the Dacom system and treat another field according to the mindset of the manager. In the beginning of the trial, there would be quite a few days different between when Dacom sprayed and when he had to spray for his own mindset. But during the season, it came together. And the last part of the season, the spraying moments of this person and of the Dacom system were the same. Of course, it could be that the man had the right feeling about it, but I think he was influenced by our system. I told you already about what we did in the United States, and in the west of the United States, in the state Washington, there's some pivots with potatoes there. Also, a research institute was testing our model, and the model told all year long not to spray. I've seen that field myself. There was no late blight in that field. There were no tracks in the field, so they were really haven't been in there. No, and the crop was clean. Still, the manager and the professor from that university, the research station, they said, well, I still gonna advise my farmers to spray because we think you have to be on the safe side. Another incident I remember is from also a research man from a university. He went to, he did a big trial for us on a commercial farm. We saved a heck of a lot of sprays there. And at a certain moment, he phoned me up from the States. He said, Jan, we have a problem. We have a big field here. We sprayed according to your system. And I found late blight, which wasn't supposed to be. I said, well, that's not too good. What did you find? Well, he said, I found 2 leaves. And you have to imagine there are about 20 million leaves on that field. So he was just kidding. There was no blight in that field at all. He thought he was a big joker.
In 2023, we started to implement the Dacom disease control in CropX. So anyone can find their disease control in CropX right now. What sets us apart from competitors is that we take into account a lot of different variables, like what kind of variety do you have in your field, what kind of weather situation, did you irrigate or not, is there a lot of rainfall or not, and also we take into account the disease pressure in the area. Do you have anything to add, John?
I think what in the parameters you have summed it up right. I think what sets us apart is that we have, for all these parameters, we have a sliding scale. And as far as I know, there's only one threshold in the whole system. And for the rest, it's all a lot to a little. But it never stops. The only threshold is in the beginning, when a farmer has sprayed and we start calculating again. There's a threshold from 2 or 3 days. But even if the calculation is you have to spray again within those 2 or 3 days, we won't warn for it because it's not practical. It's too far. But the program itself runs free, whether it's 60 days between sprays or 3 days between sprays. And I think that sets us apart from all the other systems that have thresholds and just add up a few days and then say you have to spray again without taking into account all the other parameters.
We are continuously developing our system. We are looking into different kind of combinations of data sets. Like we have our soil sensor, and we want to benefit from that soil sensor also in our disease control system. So when we measure something in the soil, like an upspike in soil moisture, we know that several hours or days before that upspike, we know that there was a rainfall event or an irrigation event. We take into account that rainfall or irrigation event in our system. What we also are developing is that we are using our as applied irrigation data and look into how much irrigation was applied. So we can use that in our model because that's a very important parameter. So we're continuously developing our system.
What I think is something for the future is where new varieties get developed. they are more resistant for late blight, sometimes with genetic modification. Regardless, late blight is let's call it a smart disease. It's already here from 1850, so it's far over 100 years, almost 200 years. If you have a resistant variety and there is an infection event coming, you still have to use another kind, a soft kind of chemical. And to know the right moment to use this chemical, you need our system. Another thing what I hope maybe people like Gert can develop in the future is when you talk about disease pressure, it also depends on what is your neighbor doing, what's happening in the area. Now we depend on information from the farmer or from people that walk in the field, but it would be nice if we could judge the number of potato fields around my field, the field that we are advising on, and based on that, we could make a judgment on the disease pressure for my field because of all the fields that are around it. If there are no fields around it, there's a low pressure. If there are a lot of fields around it, which are in good growth, we can almost estimate that there is a higher pressure. So what we have to do is take away from the farmer the questions we ask the farmer now to put into the system. We should automatically actually put them in the system already ourselves from the program itself.
We see that sustainability, CO2 footprint, and water usage is getting more and more important in the whole world. And I think that the disease control, CropX disease control, can be beneficial. If you save 1 or 2 sprayings a year, it's beneficial for the environment, for the water usage, but also for your own revenue. What we also see is that the license to produce is also getting more and more important. If I look to the Netherlands, we are going to a system that you only are allowed to use certain kind of input, chemicals or fertilizer, when you have a good reason for that. And our disease control system can help the farmer knowing when to spray and how much to spray, where to spray.